Very good morning, all the students. I hope every one of you is fine and doing well. So let's continue with the topic which we were doing already. We were doing chapter number 3, that is atoms and molecules, and in this chapter we have completed about the Dalton's atomic theory, postulates of Dalton's atomic theory, and drawbacks of the theory. So I would like to have your revision, a quick revision. So Dalton gave the atomic theory, which said that all the matter, whether it's an element or a compound, they are made up of small particles called as atom. So we have read about atom or particles, that matter is made up of tiny particles. So that particles Dalton called as atoms. So to define his theory, he also gave some postulates. So the postulates were matter is made up of very extremely small particles which are called as atom, and these atoms are indivisible. That means we cannot divide these matter further, these atom further. And then he said that they cannot be created nor be destroyed. That means they have to be there in any chemical reaction. We cannot destroy them, neither we can create them. Then he said that atoms of a given element are identical. That means any element will have all the atoms. So all the atoms will be identical with their mass, shape, size and chemical properties. That means the atoms of an element will be same. They will be alike in their mass, their shape, their sizes and their chemical properties will be same as well. Then he said that atoms of different elements will have different masses and different chemical properties. And then the next was atoms of same element have same property. Then the last one was that atoms combines in a ratio of small whole numbers to form compound. And the last one is the relative number and kinds of atoms are constant in a given compound. So that means the number of atoms will always be constant in a given compound. So out of these postulates, there are two chemical law of combination which comes from these postulates. That is, atoms cannot be created nor be destroyed. That is the law of conservation of mass, that atoms are not, they do not go anywhere, they just remain in the reaction. And the last one, the relative number and kind of atoms are constant in a given compound. That means to form any compound, we have to take a fixed number of atoms. That means a law of constant proportion. So from these two postulates, there comes the law of chemical combination. Okay, so rest of the postulates can be quite true and they may be wrong. So the drawbacks came. The first drawback was that he said that atoms are indivisible. That means we cannot divide the atoms further. But the first drawback says that the atom is divisible. That means we can divide it further into electron, proton and neutrons. That is false. The other one is that he said that the atoms of same element, that means if we take any element called as hydrogen, so it will have same mass. But this theory does not prove right for the isotopes. As hydrogen, we have seen that hydrogen itself has 3 different isotopes. That means hydrogen 1, 2 and 3. So there are 3 different atoms of hydrogen which have atomic mass of 1, 2 or 3. Because hydrogen atom has 0 neutron, but there are some hydrogen atoms which have 1 neutron and some hydrogen atom even have 2 neutrons. So the mass number, the atomic mass of an atom is mass of proton plus mass of neutron. So proton is 1, if neutron is 0, the mass will be 1, and if the proton is 1 and neutron is 2, then the mass will be 3, and if the proton is 1 and the neutron is also 1, the mass will be 2. So hydrogen has atomic number 1, but it has different mass numbers. That means this does not hold true. This property, that means atoms of same element have same masses. So atoms of same element can have different masses. They are called as isotopes. Then he said that atoms of different elements always have different masses. But again, this also not holds true. That means 2 different elements can have same masses. Okay, the masses of different element can be same, as if in the case of argon and calcium, they both have a different atomic number, but they have same mass number, so they are called as isobars. Then so the last one is that any given element have the same chemical property, but allotropes are those compounds which have the same structure, but they have the different properties. So allotropes forms of same compound but possess different property. Example, diamond graphite and one more, it's Buckminster fullerene. So they are all the form of carbon, but the properties are different, and they also are having different textures. So this is also not true. So Dalton gave the postulates. Out of those, some postulates were right, but some were proved wrong. That's why the postulates who were proved wrong, they are called as a drawbacks. Okay, so let's move to the next topic today, which is the symbols. So symbols are very important, and firstly the symbols were given by John Dalton. So Dalton gave some symbol. He was the first scientist to use symbols to represent the chemical reaction in a short way. So now why do we need to use symbols? Actually the chemical reactions are very, very big. Okay, so because the chemical reactions are so big, and we can't all the time write the whole name again and again. So in order to make these equations shorter, these symbols were used, so that and these symbols are different for the different elements, and they just define us what kind of an atom is this. But nowadays we don't use Dalton's atomic symbols. They were just formed that time because they were not convenient and they were a little difficult to draw. So they are only just having an historic importance, but we don't use it anymore. And then there were a Swedish scientist called J.J. Berzelius, who proposed that the first letter of any element will be used as the name, or the name is used as a symbol. So that is the modern symbol, but we'll be learning about Dalton's symbol, which were discovered for the first time. So here are some symbols which we do not use anymore, but they were discovered by they were just made by John Dalton. So this is a circle and a dot called hydrogen, and then a sign of this is phosphorus. So mainly the questions are asked from this: hydrogen, carbon, and oxygen. So oxygen is just a ring, and carbon is a ring with a black dot in it. Copper, a round, and a C in it. So these three are important. You don't have to learn all these symbols, because these three are only asked. So because we don't use it anymore, so they are not also used to learn. But the modern symbols are those symbols which are used these days also. So there is a branch which is called as IUPAC. That is okay. So IUPAC defines International Union of Pure and Applied Chemistry. Okay, so this IUPAC, this International Union of Pure and Applied Chemistry, it approves names of the elements. So according to this, the first name, so according to this, the first name, the first letter or first two letter. Okay, so either the first letter or the first two letter of the English name or the Latin name of the element is used as a symbol. For example, we use hydrogen. So hydrogen has the name HYDROGEN, but we use the symbol, the first name is H, so we used H. So we use H here. Okay, but if there are two different elements which have almost the same letter which starts from an alphabet. So in that case, what we're gonna do, like here hydrogen, and here it's helium. So these two letters, so these two names starts from H. So according to the IUPAC, which I have told you already, that either the symbol of an element, the first letter or first two letters are used of English or Latin language are used as a symbol. So but here the hydrogen starts from H and helium starts from H. So for that there's another rule, that in two letter symbol, the first letter is capital and the second one small. Okay, so for this now hydrogen, we will be using the first letter, that is H, but in the case of helium the first letter is H. So if we write only H here, it will be a confusion for us whether it's hydrogen or helium. So in that case we will be using the second letter as well, which is E. It will be E, and this E will be small because this second rule is that the two letter symbols, the first is capital and the second one is always small. Okay, so these are the few letters, but there are some more letters, like if we write the symbol of carbon. Okay, so carbon is starts from C, and then the other is calcium, and then chlorine and copper. Alright, so all these starts from C. So what we'll do, the first is C, the first letter is capital, but in the case of calcium the first letter will be C and the second will be used, so it will be small a. We can't write like C and A, it will be wrong. So we only write C capital and A small. Neither we can write this C and A, we can't join them, we have to write them separate. Then comes chlorine. So we'll be using the third one. Okay, so we'll be using the third letter, which is C and L, chlorine. And in the case of copper, we'll be using C and U. Cu is copper. So why is Cu here? Because copper is an English name and it was named in Latin language, which is cuprum. Okay, so like this we are having another many letters, like it's lithium. So lithium is Li, then it's beryllium. So first we like boron. Okay, boron and beryllium. So boron has atomic number 5 and beryllium has 4. So we'll write boron as B and beryllium as Be. Okay, so when the names are similar, we now these are used, like you would be wondering like why we have used only C for this and Cl for chlorine, why it we are using third letter, because they were named as they were found. So first the carbon was discovered, so the elements who are discovered first are also named first. Since the carbon was discovered first and named first, so the first letter was used as C for the carbon. After that calcium was discovered, so they used the second letter of this name, so C. So then chlorine would be discovered later after the calcium. So since the C was taken and second was taken, so for this the third was taken. So this is how it happened. And same in the case of beryllium and boron. So boron was discovered first, it was B for the boron, but after that beryllium was discovered, so it's B and small e for the beryllium. So this is how the IUPAC naming is done, and IUPAC means International Union of Pure and Applied Chemistry. So it has some rules to name the elements, and the reason for naming, for using these symbols for these elements is to make the reaction more easy for us to write, because we can't write the whole reactions in all the time, because it will require almost one page. Sometimes there are so much reaction that we will be using the whole page just to tell one reaction. So after this, there are few more names, like it's sodium. So sodium is very common use. So the symbol of sodium is Na. Why we don't use SO or S? Because sodium was named as natrium. So it's a Latin name, natrium. So the symbol was used by the this natrium Na, and N stands for nitrogen. So maybe nitrogen was discovered before sodium, so the N was used. So the second which we found from N was natrium, so it was Na. So this is how it happens. So you have to learn all the symbols. The symbols have been given in page number 51. You have to learn these names. Now these are the names of the elements, and there have been written the symbols and atomic number. So I want you to learn all the names in sequence and their symbols and the atomic number. Here are only 18 elements, so potassium and calcium you have to add. So potassium is number 19 and calcium is number 20. So the symbol of potassium is K and the symbol of calcium is Ca, and atomic number is 20 of calcium. So you have to learn all the names of the element in the sequence, because there are sequence of the elements according to their increasing atomic number in the periodic table, which we'll be learning in the next chapter or next class, in class 10. But you have to learn all these from 1 to 20, the sequence of the atomic number, increasing number, and that is why you have to learn them in sequence. So this is your homework. You have to learn this the atomic numbers and the symbols of these elements, because symbols are very helpful for us, because we'll be making formulas of these elements, and for that you have to learn the symbols and the atomic number. So atomic number, number of protons and neutrons, I think you have forgotten all these things, so I would like you to learn again a quick review of all the things which we have learned. Like this is a structure of atom. Alright, so in the center it's nucleus, so everything is nucleus. In cell also we have nucleus. So in the nucleus there lies proton and neutrons. So what are protons actually? Protons are positively charged particles, and neutrons are neutral. They don't have any charge, neither positive nor negative charge particles, and they both these things, they resides in the nucleus. Okay, so proton has mass. Okay, mass means weight. Proton has mass, neutrons has mass. Okay, so it equals to, I've written, because a proton has mass, neutron has mass, but neutrons do not have any charge. Okay, no charge. Then comes the electrons. Now electrons, they reside outside the nucleus. Like this, in the solar system there is an orbit and all the planets revolve in their path. So it's a fixed path of every electron that they are in that. So there have been discovered that there are 4 energy shells or the orbit, which is called as K, L, M and N shell. So the first one is K shell and L and M and N shell. So in this first shell there are only 2 electrons maximum, and here are 8 electrons, 4, 5, 6 and 8, and in the M shell it will be 18 and then 32. Okay, so every orbit has a set number of electrons that they cannot fill more than that. So electrons are very tiny, just like protons and neutrons, but they are negatively charged. So remember that protons are positively charged and neutrons are neutral and electrons are negatively charged. But electrons do not have any mass, no mass. So that means protons have mass and charge, neutrons have mass but no charge, electrons have no mass but charge. So the mass of the atom comprises only in the nucleus, because this whole atom is empty, as the electron is so small that we don't even consider its mass. But here the tiny part in the atom has all the mass. That means all the weight of the atom is in the nucleus. That means the atomic mass, atomic means atom's mass, atomic mass, or we can also say that mass number is proton plus neutron, or we can say that mass of proton and neutron, or we can say that the mass of nucleus. Okay, so the mass of the atom is the mass of the nucleus, because all the mass is set in the nucleus. So it's atomic mass. And atomic number, atomic number is number of proton. So in any atom, always number of proton will be equal to number of electron in an atom. But when they will be in ion formation, ion is formed when an atoms either donate or they gain any electron. So they do not have equal mass, equal electron as a proton. So proton in any atom always fixed. Proton do not move anywhere, proton do not go anywhere. Electrons, they jump from one atom to the other, they form bonds, ionic bonds, sometimes covalent bonds, but protons always remain in its nucleus. So the atomic mass is considered as the number of protons. Okay, so I think it's clear. So on this basis, there are isobars and isotopes, which we have just studied in the Dalton's postulates and drawbacks. So there are some elements which have the different mass and the same atomic number, but sometimes they have a different atomic number and same mass. So that also we'll be learning in next chapter. For your today's work, we have learned symbol. So I want all of you to learn these names of the elements and their symbols and their atomic number in sequence. And you can also learn the number of protons, neutrons and electrons they are having. This I'll be teaching you in the next chapter. So but for this chapter, just you have to learn this elements name in sequence, symbols and atomic number. This is very important for you. Okay, so then we'll be starting next topic in our next lecture. Till then, study this and try to do all the question answers. Thank you.